In this video, let's work together to build an example of a truth table for a more complicated logical expression. Now, the first thing that we do when building this truth table is identify the underlying mathematical statements that will ultimately determine all possible cases for us. So involved in this expression, we have three different letters, P, Q, and R, each representing a different, totally independent logical statement. We find then that R may be either true or false, Q may be either true or false, and P may be either true or false. And so we should have 2 times 2 times 2, altogether 8 different possible combinations of those true and false values. Now there's a very methodical way to fill these into a truth table to make sure that we have all scenarios, and it goes like this. For your rightmost mathematical statement, what we're going to do is fill in the truth table, alternating true and false all the way down for those 8 different rows. True, false, true, false, true, false, true, false. For our next mathematical statement over, in this circumstance, Q, we're going to fill in those values of true and false in pairs. True, true, false, false, true, true, false, false. And for our last example of the statement P right here, we're going to fill in those values 4 at a time. True, 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 false, 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 false. And you'll see that the list of all possible scenarios we have here starts with all different statements being true, ends with all 3 statements being false, and every foreseeable option of those 8 options is fully encompassed in the truth table. Now, ultimately, all we care about is the evaluation of this logical expression. However, this logical expression is somewhat complicated, and it's a combination of various parts of P, Q, and R. In particular, we have columns for P and Q, we have a column for R, but we don't have a column for not R, and not R is an integral part of this expression. So our very next step will be to add a column for not R, where all we do is toggle true to false and false to true for every value that appears in the R column. So while the R column went true, false, true, false, true, false, true, false, the not R column should read false, true, false, true, false, true, false, true. Now the reason that I'd really like to include this not R column is that in the previous set of videos, we discussed having a mathematical statement here and a mathematical statement here being joined with our basic logical operators like and, or, and exclusive or. So in making a column for the mathematical statement not R, I can fill in a helper column in the truth table for part of our ultimately large expression with just the Q and not R portion of this expression. And the way that I'm going to do that is I'm going to focus on my columns that I've created for the statement Q and the statement not R. And I'm going to go back to our basic truth tables, viewing the Q like the P column and the not R like the Q column right here. And anytime I see 2 combinations of true in those columns, I'll put true in the P and Q portion. Ultimately, where we're going, that will read Q and not R. And for any other combination of things that I see together, I'm going to be putting the letter F. So in this first row, one of my expressions is true while the other is false, and that's not a pair of truths, so I ultimately put an F inside this row of the truth table. In the next row of the truth table, I have a true in the Q column and a true in the not R column, and that is a situation where I would have a true output using an AND operator. My next 2 examples each contain a false, and therefore I'll put a false in the Q and not R column. After that, I have a true in the Q column, but an F in the not R column. So all together with an AND statement that will also lead to a value of false. But when I get to this next row, I encounter two true statements. And so I do put a true over here in the AND operator. And then for my last two rows of the truth table, I have a false and a false, which under AND evaluates to false, and a false and a true, which under AND also evaluates to false. So we've now created a column for the Q and not R truth values that are part of what makes up this larger logical expression. By adding these intermediate columns of not R and Q and not R, we've made it so that we can finally evaluate our full logical expression P or Q and not R. And the way that we're going to do this is very similar to what we did before. What we'll be doing is going through this table line by line, looking at things like the true over here and the false over here. And what we'll be doing in our heads is comparing those to this much smaller truth table right here. P, as it is on the more advanced logical expression, will be taking the place of this item right here. What's written as Q right here will be the column Q and not R. And what we'll be doing is looking across at the pair of values that we have in that larger truth table and figuring out what row of this smaller truth table they correspond to, and reading off the final answer for what should go in our ultimate column by the true and false values that we see over here, given the combinations over in these two columns right here. So to start out, when we have an OR statement and we're combining a true with a false, that OR statement will evaluate to true. Remembering that our OR statement is an inclusive OR statement, when we have a true and a true, we find that to be acceptable and that ultimately evaluates to true. A true paired up with a false, as it did in the first row, should evaluate to a true statement over here, and that's the same for the next row. This fifth row is our first example of having an F and an F combined with an OR statement. And that is the one situation where an OR statement will evaluate to false. So we place a false over here in this column. A false with one value being true is enough for an OR statement to evaluate to true. And then the last two rows that we see in this truth table are false, false, and then false, false again. And both of those should have the same value over here on the right as they did for this row right here. So those two cases will also lead to falses ultimately in this column. And so this is it right over here. We have listed out all 8 different envisionable scenarios, and we have a table here that tells us no matter what one of those 8 cases we're in, we'll be able to determine if this larger logical expression is true or false. You just tell me the combination of trues and falses that the P, Q, and R satisfy, and from looking things up in this chart, I'll be able to tell you whether or not this more complicated logical expression is true or false.